welcome to a video tutorial working our way through algebra word problems. In particular, we're doing a mixture of a solution problem. All right, so let's take a look at our problem. We have how many ounces of a 60% alcohol solution must be mixed with 32 ounces of a 30% solution to make a mixture that is 50% alcohol solution. All right, so what is our question? We're trying to find how many ounces of a 60% alcohol solution. There's what we're trying to find. All right, if we remember, we're taking one thing, a container of a solution, a liquid, mixing it with another container. We're trying to get just the right consistency for a total solution. And this is a mixture problem. Every mixture problem, we take something of one thing, we call it mixture A, and we're going to add to it something else, in this case, a mixture B, and we should get some sort of total mixture. Again, every mixture problem can be put in a chart of this way. All the changes is just what do we have on our side? What are our units? So we see in here we have ounces is one of our units and percents. That's what I know about what I'm mixing together. Let's make the top 1%. Let's make the bottom one recording the ounces. And this chart, it just helps us translate it and start to see what goes together in terms of making an algebra equation that we can solve. Helps us figure out what we need to find too in our variables. All right, I'm gonna have a 60% solution and a 30% solution. I'm just gonna call A my 60% and B my 30%. All right, we're good. And I know the total mixture has to be a 50% solution. So there we go, filled up that whole row nicely. What else do I know? I know that the 30% solution is 32 ounces. And now I can see what it is that I have to find. I need to find how much of A, and I don't know this, I don't know the total either. But let's think about what I'm trying to find how many ounces of the 60%. So let's make that X. Let's define that my variable. X is the ounces of the 60% solution. So I can go ahead and put an X in place right here. That's what I'm trying to find. That helps me then to see, okay, if I'm taking part A, and I'm mixing with part B to get a total, if I have X ounces of A and I'm adding that to 32 ounces of B, I need to have a total mixture of X plus 32. I still don't know what it is, but I have an expression that I can then use to get to an algebraic equation to solve. All right, let's put this thing together then. So if I'm just finding how much alcohol is in each part, 60% of my X ounces of A, so I'm going to say, all right, 0.60 of that amount is alcohol. So 60% of solution X. And I'm adding to that 30%, so 0.30, 30%, got to change it to a decimal, of 32 ounces. I'm finding the alcohol content in that part equals a total that is 50%, so 0.50, of the total amount, which is X plus 32. That's the total amount of ounces, X plus 32. That's the total alcohol. Again, hopefully it helps you see why this chart is helpful, because you can see which percent, which expressions all kind of go together in my equation. All right, let's solve this thing out now. I'm going to rewrite it a little bit friendlier. So 0.6x plus, let's multiply these together, 0.30 times 32 is going to be 9.6, has to equal, you distribute the 0.50, 0.5 times x plus, and distribute the 0.5 times 32, gives me 16. All right, let's start moving things around and solve for x here. I'm going to subtract 0.5x from both sides to get 1x on one side. That's going to go to 0. And I'm going to go ahead and subtract 9.6 from both sides to move that to the other side. All right, what do I have now? We've got 0.1x, that's 0.6 minus the 0.5, equals, that goes to 0. 16 minus 9.6 is going to be 6.4. Divide both sides by 0.1, and we get x equals 64. All right, what do we just find? Well, x is the amount of ounces of 60% solution, so we need 64 ounces, that's what we just solved for, of the 60% solution. And that answers my question. How many ounces do we need? I need 64 ounces of the 60% to mix with 32 ounces of the 30% to get a total mixture, which will be 96 ounces. That's 50%. All right. Again, it's slightly different, but hopefully it's another good example of working with a mixture problem, finding my unknowns, and knowing how to actually set these types of problems up.